Welcome back, everybody. Starting our new chapter on rational functions. And of course, we always want to start with graphing. So a rational function is basically a fraction that has polynomials for numerators and or denominators. The inverse variation function is a rational function. The parent one looks like that. The graph of a rational functions has both vertical and horizontal asymptotes. There are two curved lines on the graph. Our domain and range are from negative infinity to positive infinity, excluding the asymptotes. And for our table, as we're starting to learn how to graph, we're going to choose three values on both sides of our vertical asymptote. So this is what our parent function, 1 over x, looks like for its graph. You have your two curved lines in quadrants 1 and 3. You have a vertical asymptote at x equals 0 right along here, and a horizontal asymptote at y equals 0. So let's try a couple. We've already seen the graph for number 1, so let's talk about number 2. Number 2 is another parent function that's been stretched by a factor of 4. So our asymptotes are still at x equals 0 and y equals 0. For my table then, x equals 0 is going to be my dividing point. I need to pick three values that are less than 0 and three values that are larger than 0. Remember, whatever you pick, you plot. So I think I'm going to stick with -3, -2, -1, 1, 2, and 3. Remember, you can't pick 0 because 0 is our asymptote. And besides, if I plug 0 in right here, 4 over 0 is undefined. So it won't work anyway. So starting with, we have 4 over -3. That's -4/3. It doesn't reduce. There's no other math to do there. 4 over -2 is -2, because 4 divided by -2 is -2. And then we have 4 over -1, which is -4. On the other side, for 1, 2, and 3, we should get the exact same answers we just got, except positive. 4, 2, and 4/3. So for our graph, I'm going to go ahead and put our asymptotes in. Here's my horizontal at y equals 0. Here's my vertical at x equals 0. And then my points. I have -3, -4/3, -2, -2, and -1, -4. There's my first curve. Remember, the asymptotes guide how the curve of our line. So we can't ever cross over these asymptotes. So we make sure that we curve it, and then we get pretty snug close to those. And then on the other side, we have +1, +4, positive 2, positive 2, and positive 3, positive 4/3. And there's our other curve. So of course we can translate our rational graphs. And remember, we were just doing a over x. So how this is different is that now we're doing an h and a k. So x's, remember, are still liars. This is going to be your left or right. This one is going to be your up or down. And they also should be what your asymptotes are. So you'll notice here y equals k and x equals h. So at the bottom of your note sheet, we have A is the vertical stretch of the graph, H is the shift left or right, K is the shift up or down. And if you have a negative touching the A, it's a reflection over the x-axis. All right, let's try a couple. So here, for example, A is our 4 over x. And so this negative is going to be an x-axis reflection. This plus 2 is going to be left 2, and the minus 1 is going to be a down 1. It also tells us that our asymptotes, the vertical asymptote is going to be x equals negative 2, and the horizontal asymptote is going to be y is equal to negative 1. So now we know our vertical asymptote's at negative 2. That means that our table gets split at negative 2. Pick any 3 values less than negative 2 and any 3 values greater than negative 2. Doesn't matter, as long as you have whatever you pick, you plot. So we have, I'm going to do negative 6, negative 4, and negative 3, negative 1, 0, and 1. And what we're doing, remember, is we're plugging these x values in here. Now you can put that in the calculator all at once if you remember to do negative 4 divided by, parentheses again, negative 6 plus 2, double parentheses, and then minus 1. And so when I do that, I get 0, 1, and 3, negative 5, negative 3, and negative 7/3, or negative 2 1/3, or negative 2.33, whatever it is that you like to have there. So I'm going to have my graph. Three, 4, and negative 6. I'm going to go ahead and put my asymptotes in at negative 2 and negative 1. Remember, these asymptotes are important because they help you shape your graph and make sure that you're not going in places you shouldn't. Now, our parent functions, the two curves are in quadrants 1 and 4. So just a little refresher of your quadrants. They go counterclockwise. So quadrant 1, 2, 3, and 4. If you have an x-axis reflection, then we switch from quadrants 1 and 3, and your graph should now be in quadrants 2 and 4. If I can make that work. Well, that was not a very good one. There we go. Okay, so I'm going to go ahead and plot my points. -6, 0, -4, 1, and -3, 3. There's my curve in quadrant 3, and I'm taking these quadrants from our new set of asymptotes. And then over on the other side, I have -1, -5, 0, -3, and -1, -7/3. And there's our graph. All right, example B. So we are not adding or subtracting anything here. Our vertical asymptote is still going to be at x = 0 then. And this one is going to be an up 3. So our horizontal asymptote is at y = 3. Our table, again, will split at x = 0. I'm going to go back to a -3, -2, -1, 1, 2, and 3 on this. I'm going to plug those each into x and do that math. And when I do, I get -3, 2.3, -2, 2, and -1, 1, +1, 5, 2, 4, and 3, 3.6, 7. I'm going to go ahead and put my asymptotes in. Here is my x is equal to 0, my vertical one. And then my horizontal one at y is equal to 3. And then plot my points. So I have -3, 2.3, about here, -2, -2, about right there, -1, 1, about right here. So here's this curve. And then over on the other side, I have 1, 5, 2, 4, and 3, 3.67, and that graph. Okay, so what if we don't have the previous form, which is standard form? Another form we could have looks like this: ax plus b and cx plus d. So the vertical asymptote is found again by setting the denominator equal to 0 and solving for x. So it would start with this and then get x alone. And then the horizontal asymptote is found by, oops, let's erase that, A and C. Oh, it's not going to work. So we're putting A over C, and simplify it if you can. Divide fully if you can. It depends on what A and C are. All right, so I'm going to start over here with example 1, my asymptotes. So for a vertical asymptote, we take the denominator, which is x minus 3, set it equal to 0, and solve for x. We add 3, and we get x is equal to 3. The horizontal asymptote, we have A and C. So this is a 1 here. So y is equal to 2 over 1. I can divide 2 by 1 and I get 2. So my vertical asymptote is x is equal to 3. My horizontal asymptote is y is equal to 2. My xy table is going to be broken at x is equal to 3. So we need 3 values less than 3 and 3 values more than 3. I'm going to go 0, 1, 2, and 4, 5, and 6. Now remember, when you're plugging that into the equation, you plug it in for both x's. So 2 times 0 plus 1 over 0 minus 3, as an example. So we get negative 0.33, or negative 1/3, negative 1.5, negative 9.5. I'm sorry. I'm doing the wrong thing right here. That's a negative 5. And excuse me, plugging in the 4, we get 9, 5.5, and 4.33. So my graph is going to be kind of big. Oh, I need to fix that because I need to go down further. And I'm going to put my asymptotes in. We have x is equal to 3 here, and y is equal to 2 here. And then plotting my points, I have 0, negative 1/3, right about here. 1, negative 1.5, and 2, negative 5. I think the confusing part sometimes here is to make sure that your graph, the curve, comes up to the asymptote rather than the y-axis that we see. Then over on the right side, I have 4, 9, 5, 5.5, and 6, 4.33. So we're about there. All right, so for our second one, again, we're going to start with our asymptotes. Our vertical asymptote, we take the bottom, which is 2x minus 6, set it equal to 0 and solve for x. Add 6, divide by 2, and we again get x is equal to 3. Our horizontal asymptote, remember, is a over c. So we have 8 over 2, which is 4. Our xy table is again going to get split at x is equal to 3. So I have 0, 1, 2, 4, 5, 6. And again, you do not have to use these 6 values. That's the one that I'm picking to use. You can pick whatever you want. And then you're plugging those in to both x's and doing that math. So we get negative 0.5, negative 2.75, and negative 9.5. And then 17.5, 10.75, and 8.5. So see, maybe you might even want to pick 7 down here so you don't have to graph that 17.5. But again, that is completely up to you. So if I'm sticking with that, I need a really big graph. I think I'm going to go by 2's here. So that's negative 4, negative 8, negative 10. And by 2's here, 2, 4, 6, 8, 10. Oops. 10, 14, 18. All right, drawing my asymptotes at x is equal to 3 right here, and y is equal to 4. Remember, I went by 2's, so it's here. And plot our points. We have 0, negative 0.5, 1, negative 2.75, and then 2 is negative 9.5. So our graph's going to do something like this. And then 4, 17.5, 5, 10.75, and 6, 8. And there's that graph. This is where we will stop for today. We will pick up again tomorrow night with the rest of your notes. Have a great night.